What if I told you that the sheer physical weight of your own body, like the actual pressure of you sitting in your chair right now, wasn't determined by a collection of tiny, solid, microscopic billiard balls,
Right.
but that it was actually the result of a four-dimensional geometric lock? Or, to take it even further, what if nothingness itself isn't an empty void, but this tightly coiled, vibrating structure?
Yeah, that is the core of it.
Because if you are someone who loves peering behind the curtain of reality, you're probably pretty tired of theoretical physics being presented as this impenetrable wall of equations. Equations that seem to have absolutely zero bearing on the macroscopic world we navigate every day.
Exactly. It can feel very disconnected.
Right. So today, we are peering past that ultimate boundary. We're exploring a question that sounds absurdly simple, yet it threatens to break open our entire understanding of physics. We are asking, what is inside zero?
And, the phrasing of that question is crucial here. Well, the traditional assumption in physics is to ask if zero is empty, or maybe what happens when variables simply approach zero. But the researchers we're studying today, they didn't look at zero as an absence.
Right, not just a blank space.
Exactly. They approached it as a specific, highly structured state of existence. They were basically asking, what is the internal architecture of nothingness?
And to explore that, our mission for this deep dive is to synthesize a massive stack of sources from a multi-year, rigorously documented scientific program. This is a massive physics formalization campaign dated July 26th, 2026.
Yeah, and it's important to note what we are actually looking at here. What we have isn't a polished textbook.
Right, it's pretty raw.
Very raw. We have the internal working documents. We're talking mathematical proofs, conceptual memos, and the architectural frameworks of a team that is trying to map how the solid everyday world emerges from a hidden, incredibly complex relational substrate.
Okay, let's unpack this. We have to start where this entire program started. And strangely enough, it wasn't with a chalkboard full of math.
No, it really wasn't.
It began with an internal document labeled Addendum 11, which details what the author called a recursive encounter within the dream field. Now, I gotta say, that sounds like mysticism, not physics.
It does, yeah. It sounds highly unconventional, but we really have to treat it the way physicists treat Albert Einstein's famous thought experiment about chasing a beam of light.
Oh, like when he pictured himself riding a light wave.
Okay, exactly. It's a conceptual starting point. It's a geometric visualization that gives the rigorous math a place to anchor itself later on.
Makes sense.
So this document outlines a three-stage sequence of emergence from this absolute baseline state. It's an attempt to describe how structure can possibly arise from a completely unconditioned substrate.
And the progression they describe in the text is just incredibly vivid. Like, stage one is called the line.
Right.
The author writes about a directional extension emerging from a dark substrate. It's vibrating, it's unfolding, and it possesses just the barest hint of dimensionality.
But it's unstable, right?
Yes, highly unstable.
Yeah.
Because a line just extending infinitely doesn't hold anything.
Yeah.
So it has to evolve into stage two, which they call the circle. The directional line basically curves and connects back to its own origin.
Yeah.
And the text specifically notes, and I'm quoting here, from the substrate, zero formed, not as emptiness, but as vibration, oscillation, resonance, and coherence. And they define the formation of this circle as the literal birth of memory.
Which is such a wild concept, but the connection between a geometric circle and the concept of memory is fundamental to their entire framework.
Break that down for me. Why is a circle a memory?
Think about what memory actually requires to exist. In a completely linear, unconstrained environment like that stage one line, an impulse just travels outward infinitely and dissipates.
Right, the information just flies away and is lost.
Exactly. So for information to be retained, for a system to have a state that it can refer back to, the process must loop back on itself.
Oh, wow.
Yeah. The circle is the absolute simplest geometric representation of a closed feedback loop. It's a self-referential structure. That is what a memory is at a physical level.
Okay, so a closed loop is a memory. But if the universe just stayed a circle, nothing would ever happen. It would just be a static loop forever.
Nothing would change, correct?
Which brings us to stage three, and this is called the twist. The text says that this closed loop undergoes a specific physical torsion, turning the circle into a figure eight, the shape of infinity.
The infinity topology, yes.
And the author recognizes this specific geometric transition as the absolute foundation of all physical emergence. I want to ground this for the listener because earlier I was thinking about a rubber band.
That's actually a perfect analogy.
Right, like if you hold a rubber band in a perfect circle, that represents their concept of zero. It's a closed loop holding tension. But if you pinch the middle and twist one side, it snaps into a figure eight.
It does.
And the documents refer to that exact center point, the hinge of the twist in the rubber band, as ZDV, the zero-degree vantage. So my question is that twist the exact mechanical moment where an abstract memory loop physically condenses into actual matter?
Well, the mechanism they are proposing is a bit more nuanced than matter just simply popping into existence at the twist.
Okay.
The torsion creates what they call the quadratic field dynamic. The ZDV is a torsion gate. When you twist that rubber band, you introduce a structural conflict.
Because the loop is now fighting itself.
Exactly. The geometry is in conflict. And this begins a very specific chain reaction. Strain forces curvature, curvature sustains resonance, and resonance finally stabilizes into coherence.
I can actually visualize that with the rubber band. The strain of the twist forces the rubber to curve in a new way, and it vibrates like it physically resonates until it settles into that stable figure eight shape.
Right, and exactly that structural stabilization is what they call full zero.
It's full zero.
Yes, because standard physics treats zero as a coordinate on a graph. Right, just an absolute void. This framework defines zero as a coherent saturated substrate. It is packed with latent energy held in tension.
So it's not empty at all. It's completely full.
It's as full as it can possibly be. And that figure eight topology, the infinity symbol, it represents a dual action. The inward spiral is the system holding recursive memory under immense torsion. It's storing its own history.
Okay.
And the outward arc of the figure eight is the projection of identity. It's the system emitting scalar coherence into the environment.
So the inward loop remembers and the outward loop projects.
You've got it. The tension between the two is what actually generates the observable properties of a particle. The implication here is staggering, really. The fundamental building blocks of reality aren't objects.
They aren't things.
No, they're relationships. Before any particle can exist in space, the underlying relational fields have to twist, encode their state as a memory loop, and then project a coherent emission.
That fundamentally shifts how you look at the world. Let's bring this back to the person listening right now. If this framework holds true, every single physical object you interact with today, your coffee cup, the floor beneath you, the very cells in your body, it isn't made of inert stuff.
No.
It is entirely composed of this hidden portion. It's this endless sea of twisted zeros projecting outward arcs that your brain just interprets as solid matter.
It's an incredibly beautiful way to model reality.
It really is. But having a beautiful geometric vision is the easy part. Translating a twisted rubber band into hard physics that actually pays rent in the real world is a completely different game.
Yeah, that's where the math has to come in and prove itself.
Exactly. How do they move from this vision of a twist to actual testable numbers?
Well, they chose one of the most notoriously difficult numbers in physics as their proving ground. They went straight for the proton-electron mass ratio.
Okay, why that number specifically?
Because it is a massive unsolved hurdle. The ratio is roughly 1836 to 1, meaning a proton is about 1826 times heavier than an electron. An electron is incredibly light, a proton is massive.
Right.
And predicting the exact ratio of their masses purely from first principles, meaning without just measuring them in a lab with instruments and plugging the numbers into an equation, that has eluded theoretical physics for decades.
And the documentation shows they achieved a 0.00075% precision on this calculation.
Yes.
Which is mind-blowing. But I have to emphasize something from the notes that really stood out to me. They did this using zero free parameters.
That is the crucial part.
To me, a free parameter is basically a mathematical fudge factor. It's when a physicist says, well, the equation doesn't quite balance out, so let's multiply it by 14.2 because that makes it magically match what we see in the telescope.
Exactly. Standard models rely heavily on them.
But this team didn't supply the answer at all. The geometry dictated it entirely.
The rigorous nature of this really cannot be overstated. They derived the mass ratio by connecting three fundamental constants, and none of which they invented, by the way.
These are established constants.
Yes. First, they used phi, the golden ratio, which governs structural proportions and emerges completely naturally from icosahedral symmetry.
Okay, phi.
Second, pi, the foundational constant of angular and circular geometry. And third, alpha, which is the fine structure constant that determines the strength of electromagnetic interactions.
But they didn't just throw these numbers into a blender and hope for the best. The sources go into heavy detail about the use of something called the 600-cell geometry and a base 60 counting system. They call it theta 60 phase quantization.
Yes.
I can grasp a 3D shape, like a cube or a sphere, but what on earth is a 600 cell?
So to visualize a 600 cell, you have to start with a 3D icosahedron. That's a solid shape with 20 triangular faces, commonly known as a 20-sided die in tabletop games.
Okay, got my 20-sided die.
Right. The 600 cell is its four-dimensional equivalent.
Oh, wow.
Yeah, so instead of 20 flat triangles, it is composed of 600 three-dimensional tetrahedrons. It's a hypershape. It has exactly 120 distinct vertices.
That is hard to picture.
It is. Our brains aren't built for 4D. But mathematically, the researchers mapped the elements of a specific mathematical symmetry group directly onto these 120 vertices. And within that staggering 4D architecture, they found a critical lock angle of exactly 36 degrees.
And that 36 degrees is deeply coupled to the golden ratio.
Yes, intrinsically.
So they're literally pulling the mass of a proton out of the physical angles of a four-dimensional hyperjoule.
It sounds like fantasy, but mathematically, the mass is just a consequence of the geometry stabilizing itself. They formalize this entire process into what they call the lock potential formalism.
Okay, let's get into that.
The core coupling equation, the actual math that connects the geometry to physical mass, it relies on two critical variables interacting. The equation takes the absolute value of a sine wave based on the system's history parameter, and it multiplies it by the absolute value of a cosine wave based on future constraints.
Okay, I want to break this down without making you, the listener, feel like you're suddenly trapped in a college calculus lecture.
Please do.
So the equation in the text is C sub n equals the absolute value of sine of f times delta phi, multiplied by the absolute value of cosine of nu times RCR.
Exactly.
So you've got sine representing the delta phi, which they call phase difference, or basically the history of this system.
Right.
And you've got cosine representing the RCR, which stands for recursive coherence restoration, or the future constraint.
Yes, past and future.
Why multiply sine and cosine together to find mass? Like, what is the physical meaning of doing that?
Well, think about waves on the surface of a drum.
Okay.
The sine wave represents the history of the drum head. That's the initial strike radiating outward from the center.
Got it.
The cosine wave represents the boundary constraint. That's the rigid metal edge of the drum forcing the wave to bounce back inward.
Oh, I see.
So when an outward sine wave and an inward cosine wave multiply and interfere with each other, they create standing waves. Certain specific points on the drum head lock into place and literally don't move, while other areas around them vibrate intensely. The geometry of the drum dictates exactly where those stable, non-moving nodes form.
And in this 4D geometric framework, those stable, non-moving nodes are the masses of the proton and the electron.
Exactly. They are structural inevitabilities of the geometry. They're not just random chunks of matter floating around.
That is so elegant. And then the text says they applied a final electromagnetic correction of alpha divided by 10 to that geometric lock, and boom, 0.0000075% precision.
It is a towering scientific achievement.
It really is.
Yeah.
But I am going to push back hard here because the internal documents do something remarkable, honestly. They actively highlight their own failures.
They do, yes.
I read this section documenting their attempt to apply this beautiful, perfect 4D lock potential to the muon. Now, the muon is fundamentally just a heavier cousin of the electron, right?
Yes, it's basically a heavy electron.
So it should play by the exact same rules. But when they ran the muons through this new mathematical framework, they got a 1.863% error.
Which is huge.
Yeah. In particle physics, a 1.8% error means your bridge just collapsed into the river.
It's a complete structural failure, yes.
So if the math fails that spectacularly on the muon, doesn't that imply this whole thing is just a really complex, math-heavy, curve-fitting exercise? Like, did they just build an incredibly convoluted equation perfectly tailored to find the proton and electron, but it's completely useless for anything else?
It's a very fair question, and the researchers actually dedicate an entire section, the FP1 First Principles Examination, to interrogating that exact doubt.
So they knew it looked bad.
Absolutely. They don't hide from the muon error at all. They conclude that their framework, in its current state, acts as a quote-unquote best pair finder.
That's pair finder.
Right. It perfectly isolates the most stable configuration in the universe, which is the proton and the electron, but it cannot yet systematically derive the entire hierarchy of heavier, unstable particles like the muon without introducing massive errors.
I mean, it takes immense intellectual honesty for a team to say, look at this miracle we built.
Right.
And look at how it breaks when you push it.
The scientific integrity is absolute. However, The FP1 examination also levels a fairly devastating critique at the current standard model of
Oh,
physics.
how so?
Well, the standard model is our best accepted theory of reality, right? Yet it does not derive the masses of particles from first principles either. It measures them experimentally in a collider and just plugs the numbers into the equations by hand.
So it doesn't know where they come from.
Not at all. It cannot explain why there are exactly 3 generations of particles or why the muon weighs exactly what it does. The standard model supplies the parameters. It doesn't explain their fundamental origin.
That is a fascinating distinction and failure. The standard model basically says, we don't know why these numbers exist, so we'll just write them in to make the math work.
Right.
This geometric framework says, these numbers must exist because this 4D shape demands them, but we just haven't figured out how the shape bends for the heavier particles yet.
Exactly. Even with the muon error, the philosophical shift here is undeniable.
Yeah, because if mass is just a geometric lock, then the universe is less like a random bucket of spare parts and much more like a breathtakingly intricate origami sculpture.
The shift in ontology is profound, but reaching that level of extreme precision on the proton forced a massive reckoning within the team.
What do you mean?
To fix the muon error, they realized they had to understand their own equation at a microscopic level. They had to look at those 2 variables we mentioned earlier, the history parameter, delta phi, and the constraint parameter, RCR.
Right, the sine and cosine stuff?
Yes. They had to map their exact physical behaviors, and when they subjected those specific terms to intense scrutiny during what they called the ring survey campaign, the terms began to shatter.
And this brings us to section 3, the fracture. Standard physics, and even this research team initially, treated these variables as atomic concepts, right?
Yes.
Like they thought RCR, this whole idea of a system returning to a coherent state, was one single solid brick of logic.
But when they zoomed in, they found it was hollow. And inside that brick was a tangled knot of bundled mechanisms.
So the assumption of unity just collapsed.
Entirely. They realized RCR actually contained distinct phase relationships, localized memory structures, and multiple independent return-to-reference pathways. Treating it as a single variable was blinding them to the actual mechanics of what was happening.
And this fracture did just affect their new math. It cascaded backward into the bedrock concepts of traditional physics. Because one of the most alarming casualties in this document was the concept of momentum.
Yes.
Here's where it gets really interesting. Because in our daily lives, we use umbrella terms all the time. Think about your bank account.
Yeah.
If you say to someone, I have money, what does that actually mean?
It could mean a lot of things.
Right. Money could mean physical cash in a vault. It could be a pending credit authorization. It could be a highly volatile stock option, or it could be a massive mortgage debt.
All very different things.
Completely different. And if you just label all of those completely different structures as money and try to predict how they will react to a change in interest rates, your entire financial model will implode. Cash and debt react to the same force in literal opposite directions.
That's a great way to put it.
And the documentation reveals that standard physics has been treating fundamental concepts exactly like that.
They have. The BA2 phase of their research painstakingly deconstructs the word momentum. They found that the word momentum in the standard literature actually refers to at least 15 distinct mathematical and physical objects.
15. That sounds completely unmanageable for a science that prides itself on precision.
It's a massive conceptual crisis. Standard physics routinely conflates noether momentum, which is an abstract conserved charge derived from spatial symmetry,
Right.
with kinetic momentum, which is the literal physical mass times velocity of a moving object.
Totally different things.
Entirely. And then you have canonical momentum from phase space modeling, field momentum in electromagnetism, probability currents in quantum mechanics. I mean, these are not interchangeable synonyms.
Right.
They obey entirely different mathematical rules, yet they are all just shoved under the exact same umbrella.
The sources use the hydrogen ground state insight to prove how deeply flawed this is, and I have to admit, this completely upended how I picture atoms.
It does that to everyone.
Let's walk through this one. If you take a standard hydrogen atom, one proton and one electron in its absolute lowest energy state, you measure the kinetic energy of that electron, and it is 13.6 electron volts.
Right.
So it clearly possesses energy associated with motion. But if you calculate the average momentum of that exact same electron, it is exactly 0.
Yes.
How is that physically possible? How can a particle possess kinetic energy but have absolutely 0 momentum?
Because the macroscopic analogy we were all taught in middle school. a tiny electron spinning around a proton like a planet orbiting a star, is fundamentally false.
Wait, really? It's not orbiting?
No. If the electron were actually orbiting in a circle, it would have angular momentum. But in the ground state, the electron's probability distribution is perfectly spherical and entirely stationary.
It's not spinning at all.
It's not spinning. It is a standing wave encompassing the proton. The momentum vectors in every possible direction cancel each other out perfectly to zero.
So when a textbook says the hydrogen atom, quote-unquote, maintains momentum, it doesn't mean a tiny physical ball is continuously moving around.
No, not at all. It simply means the mathematical probability distribution remains stationary over time. The energy is bound in the structural tension of the standing wave, not in classical motion.
That is wild.
And this shatters our reliance on Noether's theorem as a fundamental explanation. Noether's theorem is this brilliant piece of mathematics that proves if a system's space is perfectly symmetric, its momentum will be mathematically conserved.
It sounds like a solid rule.
It is a solid mathematical rule, but the researchers point out a massive physical blind spot. Noether's theorem proves a correlation, but it offers zero ontological explanation. It doesn't explain what momentum actually is physically, nor does it explain why the underlying space possesses that translation symmetry to begin with.
It's like having a map that perfectly and accurately predicts the territory, but absolutely refuses to explain who built the roads.
That's exactly it.
And they found the exact same fracture in the concept of back action. In physics, back action is the idea that simply interacting with a system alters it.
Right. This observation changes the system.
But they split back action into 4 entirely different physical mechanisms.
And the distinction between what they call C1 and C2 back action is the clearest example of this fracture. C1 is dynamical loading.
Okay, what does that mean?
If you push a copper wire through a magnetic field, the field physically pushes back on the wire. You feel physical resistance in your hand. That is classical back action.
Got it.
C2 is measurement disturbance. If you shine a single photon at a quantum superposition just to see where it is, the superposition collapses. That is a purely informational, probabilistic disruption. Grouping physical magnetic resistance and quantum wave function collapse under the exact same word, back action, it guarantees mathematical failure at the limits of precision.
Because you're equating physical force with informational collapse. Precision requires dismantling the familiar. We cannot build a new framework of reality using broken tools.
You really can't.
And because these fundamental concepts fractured so violently, the researchers arrived at a terrifying realization. The quote-unquote reality that human beings measure, the equations we use, the macroscopic world we see, it is just one highly specific, severely filtered output layer of a much deeper chaotic ocean.
The fracturing of terminology made it undeniable that our physical models are not describing the root of the universe. They are describing the exhaust of a hidden engine.
The exhaust.
Yes, and this forced them to formulate their 3-layer architecture.
Okay, let's dive right into section 4 and build this architecture layer by layer, because this is where the twisting figure 8 and the geometric locks all find their permanent home.
Right.
The foundational premise here is that oscillatory dynamics, which they abbreviate as OD, and which represents basically every physical thing we can see, touch, or measure, is not the bottom of reality. So what lies beneath OD?
At the absolute bottom, forming the completely unobservable foundation of reality, is layer 1, relational mechanics, or RLM.
RLM.
Yes. This is the complete unbounded state space. It contains every single physical degree of freedom, every microscopic relationship, every entanglement, every potential state the universe could possibly hold.
And we can't see it.
It is entirely unobservable because of its sheer density and lack of distinction.
It's just the raw, unfiltered data stream of the universe. But we don't experience RLM because between us and that raw data is layer 2.
Layer 2 is resolution mechanics, or RSM.
Right.
RSM functions as an active aperture, a dynamic filter. Its entire purpose is to process the infinite complexity of the RLM layer through 3 distinct operations. It selects, it suppresses, and it integrates.
So if RLM is the complete universe of all quantum possibilities, the RSM layer acts like a highly aggressive compression algorithm.
That's a great way to think of it.
Like, think about a raw 8K video file. It's too massive to stream over a standard connection. So the compression algorithm looks at the raw data and says, I'm going to throw away 90% of these pixels, I'll blur the background, and I'll only keep the sharp edges of the actor's face.
Right.
The output is a smaller, manageable file. RSM is the universe's compression algorithm. And what it chooses to output, what survives the filter, is layer 3, oscillatory dynamics.
The OD layer is what we mistakenly call objective reality. But the sources are fiercely specific about what kinds of signals actually survive the RSM filter. Not just any compressed data becomes a physical reality.
Right.
To exist in the OD layer, a signal must possess quote-unquote phase-bearing recurrent exchange.
Unpack that phrase for us. Why phase and recurrence?
Because without recurrence, an event happens exactly once and instantly fades into the background noise. It's gone. And without a phase, a structured peak and trough, there is no coherent information to exchange with other systems.
That makes sense.
Imagine striking a tuning fork in a vacuum. It vibrates, so it has phase and recurrence. The resonance sustains itself through a complex conjugate pole, meaning the mathematical structure of the vibration oscillates symmetrically across an axis.
Okay.
That symmetry prevents it from immediately dampening into zero. If it didn't possess this mode-locking capability, if it just suffered monotonic decay and faded away, it would be suppressed by the RSM filter entirely.
So the filter only allows things that ring like a bell. If it's just a dull thud, it gets suppressed.
Exactly.
And the documents emphasize that we cannot treat suppression as just a single trash can where discarded data goes. The filter is typed.
Yes, typing the suppression was a major breakthrough for them. If the RSM filter suppresses a signal, the researchers aggressively demand to know the exact physical mechanism.
How's it destroyed?
Right. Was the signal destroyed by dephasing, where the waves lost their synchronization? Was it destroyed by damping, where energy was leached into the environment? Or was it canceled by destructive interference?
Whereas standard physics often just zeroes out the equation and moves on.
Exactly. This framework tracks the specific mechanism of exclusion.
Because the way something is excluded fundamentally defines the shape of what remains. Which leads us to one of the most brilliant concepts in the entire stack. The redefinition of a groove.
Oh, this chart is fascinating.
It really is.
Yeah.
In classical computing or physics, a stored state is basically like a file on a hard drive, right? It's a static piece of data waiting to be read. But in the context of resolution mechanics, a groove is something entirely different.
The researchers define a groove not as stored information, but as a stable bias in the selection map of the RSM filter.
A stable bias.
Yes. It is a pathway of least resistance that makes certain physical trajectories highly derivable while aggressively suppressing others.
The vinyl record analogy they use in the memos is just the absolute perfect way to visualize this.
It really clarifies it.
If you look at the physical groove pressed into a vinyl record under a powerful microscope, what do you actually see? You don't see sound. There is no audio trapped in the plastic. There are no tiny sound waves frozen in time. The groove is purely a geometric configuration of the medium.
Precisely. The groove itself is entirely silent, but when a stylus, the needle of the record player, drags through that geometry, the groove actively biases the movement of the stylus.
It forces it to move in a specific way.
It forces the stylus to vibrate in a highly specific, constrained pattern. The interaction between the stylus and the geometric bias rederives the sound in real time.
The sound isn't stored, the interaction is configured, and that is what reality is in this framework. Like the mass of the proton, the orbit of a planet, the solid desk sitting in front of you right now, these are not objects storing mass and energy. They're incredibly deep, stable grooves in the underlying geometric substrate of the universe. The oscillatory dynamics, the reality we experience every day, is just the stylus of our perception dragging through the grooves of the resolution mechanics filter.
It completely reverses the arrow of causation. Matter isn't producing the geometry. The geometric bias is producing the matter.
I really want the listener to sit with that for a second. The solid world you interact with every day is just the sound playing off the record. You're living entirely in the filtered output.
It's a humbling thought.
It is.
Yeah.
But this forces a massive, unavoidable question, which brings us to Section 5. If the RSM filter acts as a bouncer, turning away 99% of the quantum relationships and suppressing them so we only see the macroscopic grooves, where does the suppressed information go?
Right.
Does it just vanish from the universe entirely?
Standard physics often treats suppressed microscopic data as functionally irrelevant to macroscopic equations, but this framework establishes a fundamental, unbreakable rule. Smear is quotient, not blur.
Smear is quotient. Let's really dig into this because this concept changes how you look at the physical space around you. When physicists look at the macro world, say a continuous smooth field of gravity or a solid sheet of metal, they know that underneath it, the quantum world is chaotic, discrete, and jagged.
Yes.
So historically, we've thought of the macro world as a blurry photograph of the quantum world. If you zoom out far enough, a million jagged pixels just blur together into a smooth gray square.
But the internal documents reject the blurry photograph concept with extreme prejudice.
Why?
Because a blur implies a simple loss of optical focus. A quotient is a highly specific mathematical operation. In a quotient operation, you take an incredibly diverse set of microstates, you group them together, and you declare them to be an equivalence class.
Explain that declaration. What does it mean to mathematically declare an equivalence class?
It means the filtering aperture actively imposes a rule that says, I am choosing to treat all of these highly distinct quantum fluctuations as completely indistinguishable from one another.
Okay, I see.
The smoothness of the metal sheet isn't because the universe is out of focus. The smoothness emerges because your specific observational aperture lacks the resolving power to distinguish the microboundaries, and so it mathematically quotients them into a single unified block called metal.
So the continuum of space and time isn't a fundamental reality. It's the mathematical consequence of our own blindness to the micro details.
Exactly.
But the critical part of the quotient operation is that the details you ignored don't cease to exist. They leave a ghost behind. The documents call this smear residue.
And to really understand smear residue, we have to look at the Zwanzig-Mori projection operator formalism.
That sounds intense.
It is a formidable piece of mathematics used in statistical mechanics, but its philosophical implication is profound. The formalism dictates that when you take a vast, complex system and project out all the fast or irrelevant microscopic variables to focus only on the slow macroscopic variables, the equation doesn't just cleanly simplify.
You can't just hit delete on the fast variables and walk away.
Exactly. The mathematics physically forbids it. When you project out the microdetails, the resulting equation is forced to generate two new terms to balance the ledger.
What are they?
The first is a memory kernel, which represents how the current state of your macro system is still constrained by the history of the micro variables you tried to ignore.
Okay.
And the second term represents fluctuating noise.
Wait, so what we casually write off as just random noise in a system isn't random at all?
It is the exact opposite of random. Noise is the highly structured, dynamical footprint of the excluded information. It's the smear residue.
Wow.
The universe simply doesn't let you delete data for free. It transforms the deleted data into friction and noise that continuously agitates the macroscopic layer.
And this mathematical inevitability leads to the single most elegant convergence in the entire deep dive, honestly. Because of this Zwanzig-Mori formalism, the researchers proved that memory and back action are not two separate physical phenomena.
They are the exact same phenomenon manifesting through different signatures.
Break that down.
When the suppressed quotiented structure bleeds back into the observable system over time, constraining its future evolution, we call that temporal signature memory.
Okay.
When that exact same suppressed structure exerts a direct physical force on the observable system in the present moment, we call that dynamical signature back action.
So what does this all mean for us? It means the concept of nested resolution completely defines reality. Just because a quark or a photon looks fundamental to us doesn't mean it's the absolute bottom layer of the universe. High resolution is a completely relative term.
Exactly. It's high resolution only in relation to a declared lower resolution aperture. It's like discovering the pixels on a computer monitor and declaring them the fundamental building blocks of the digital world.
Right.
The pixel is just an emergent output quotiented from the deeper logic gates of the graphics processor, which itself is quotiented from the underlying flow of electrons.
But the documents are very careful not to let this slide into, like, nihilism. Just because the macroscopic world is emergent, just because classical spacetime is a quotiented illusion of our aperture, does not mean it is fake.
No, not at all.
The macro world is completely causally effective at its own scale.
The analogy they use is a sound wave. A sound wave is a collective, emergent excitation of billions of individual air molecules. You cannot point to a single nitrogen molecule and say, that molecule right there is the sound wave.
Because it's a collective behavior.
Right. The sound wave is a quotiented description of the collective. Yet that emergent, non-fundamental sound wave can travel across a room and literally shatter a crystal glass. The macro description wields objective physical power.
So when you look at a wall, you are seeing a stable description of everything your eyes cannot distinguish. The continuum is made of your blindness, but that blindness is dense enough to stop a bullet.
It's beautifully put.
But this entire architecture, the RLM, the RSM filter, the quotienting of smear, It balances on a razor's edge. Because if the reality we measure depends entirely on the aperture observing it, we absolutely have to define the observer.
We do.
If we don't, the whole framework collapses into subjective solipsism, where nothing is real unless a human looks at it.
And this is historically where quantum mechanics starts to sound like really bad philosophy. The observer effect in quantum mechanics, the fact that simply measuring a particle forces it to choose a definite state, has sparked decades of debate.
Because standard physics rarely defines what an observer actually is.
Exactly. Does wave function collapse require a conscious human mind? Does a digital camera count? What about a rock interacting with a photon?
The research program recognized this theoretical danger immediately. The notes say that on day 55 of their campaign, they hit the brakes. They formally parked the concept of the internal observer.
Yes. They realized it was being used as a rhetorical crutch to explain away the math without providing an actual physical mechanism. They demanded a rigorous definition of an observer that did absolutely not require human consciousness.
And their candid definition is dense, but it is mathematically tight. It says, an observer is a bounded system whose aperture index readouts update an internal relational state that conditions subsequent physical action.
It's a mouthful.
Let's break that down using the automobile metaphor they developed because it completely clarified this for me. In this metaphor, the observer is not the human driver alone. The observer is the integrated system of the driver and the vehicle acting as a single bounded unit.
Correct. And this bounded system navigates reality by utilizing multiple, highly specific, limited apertures.
Okay, what are the apertures?
First, you have the windshield. This is a broad perspective aperture. It provides a forward-looking, real-time data stream of the environment you are entering.
Nonsense.
Second, you have the rear view and side mirrors. These are rearward and lateral constraint apertures. They don't tell you where you are going. They supply hard limits on what actions are currently forbidden based on what is behind you.
Right.
Third, you have the dashboard, the speedometer, the fuel gauge, the check engine light. This is an integrated computational readout of the system's own internal state.
And the crucial realization is that absolutely none of these apertures present the raw, objective world to the driver. The windshield distorts light, the mirrors have massive blind spots and alter your depth perception. The speedometer only gives a numeric quotient of rotational tire velocity.
Exactly. The observer never interacts with the raw RLM substrate. The observer constructs a synthesized internal estimate of reality by weighing the inputs from these differently constrained apertures.
Okay.
And this is the vital part. The observer's subsequent physical action, like turning the steering wheel or hitting the brakes, is conditioned entirely by that synthesized internal state, not by the raw universe.
And a tiny input from a highly constrained aperture can exert massive causal weight. Like if you glance at your side mirror, which takes up maybe 2% of your visual field, and you see a massive semi-truck in your blind spot, that tiny sliver of filtered data completely dominates your integrated estimate.
You do not change lanes.
Exactly. The internal state updates, and the physical action of the car is conditioned by the constraint.
Therefore, in this physics framework, an observer is simply a physical control loop. It is any bounded system that takes in filtered data, updates an internal physical state, and alters its next physical interaction based on that updated state.
Under this definition, a programmable thermostat is a minimal observer. A human being is just an exponentially more complex control loop. Consciousness is not a prerequisite for reality to function.
It removes the mysticism entirely.
But just as they ground the observer in practical physical control loops, they connect this observer to time in a way that is utterly mind-bending. This is section 6, where the internal architecture collides with the two-state vector formalism, or TSVF.
TSVF is an existing, highly controversial interpretation of quantum mechanics developed by physicists Yakir Aharonov and Avshalom Alitzer.
Okay, what does it propose?
It attempts to explain the bizarre retroactive behaviors seen in quantum experiments. TSVF proposes that quantum systems are not merely pushed forward by the history of the past. They are simultaneously pulled backward by the conditions of the future.
The future pulling the present backward? I mean, it sounds like science fiction.
It does, but the math is incredibly robust. TSVF utilizes two state vectors to describe a quantum system. You have the forward state vector, labeled psi, which evolves forward in time from the system's initial preparation in the past.
Right, that's standard.
But you also have a backward state vector, labeled phi. This vector evolves backward in time, originating from the final measurement that will be made on the system in the future.
Wow.
The actual physical reality of the particle in the present moment is generated exclusively by the overlapping interference of both the past and future vectors.
And when the team running this 2026 formalization program checked their own math, specifically that geometric coupling function we spent so much time on earlier, the absolute value of the sine of history multiplied by the cosine of the future constraint, they discovered a mathematical correspondence that is literally impossible to ignore.
The structural match is exact. When they mapped their lock potential equation against the TSVF weak value amplitude, the mathematical outputs matched to a precision of 10 to the negative 16th power.
That is 16 decimal places of perfect alignment.
Verified across 2,500 individual test points.
You don't get 16 decimal places of precision by coincidence. The universe is telling them that their geometric locks and the forward-backward flow of time are intrinsically the exact same mechanism. Elitzer, one of the original creators of TSVF, has a quote about this that feels like it unlocks the whole mystery.
He suggests that the actual quantum mechanical interaction doesn't even happen within normal space and time.
Yep.
He theorizes that the fundamental interactions occur in the unconditioned substrate outside of our space-time continuum, what this program would call the RLM layer.
And his quote is just wild. He said, "Give me a history when you have fake future and fake past. But give me an experiment in which there is an overlap between them. The place where they overlap, here you're going to get a real particle."
It's incredible phrasing.
The wording is wild, but the concept is profound. The fake past is the forward computed probability of where the particle might go. It hasn't collapsed yet, so it's not real. The fake future is the backward computed probability of where the particle must have come from to hit the final detector. Neither timeline is independently real.
No, they're just probabilities.
But in the exact coordinate where those two phantom probabilities intersect, where the sine of history crashes into the cosine of future constraint, the tension sparks reality into existence. The present moment is basically forged in the pressure cooker between what was and what must be.
And this bidirectional pressure leads to consequences that break traditional physics entirely, most notably the emergence of negaparticles.
Negaparticles.
Yes. When physicists run the TSVF math in the weak measurement regime, the equations occasionally yield a negative value for mass or kinetic energy.
Which shouldn't be possible.
Aharonov and Elitzer argue this isn't just a mathematical artifact to be discarded. They suggest that for incredibly brief durations, the overlapping vectors demand the existence of particles with literal negative mass.
And just to clarify for the listener, this is not antimatter. Antimatter, like a positron, still has regular positive mass.
Right.
It just has an opposite electrical charge. A negaparticle would have negative mass. If you physically pushed it away from you, it would accelerate toward you.
It violates classical intuition completely. But despite the math matching to 16 decimal places, the researchers document an incredible degree of caution.
Yeah, I noticed that.
In their notes, they categorize the physical mechanism for TSVF as an open question, labeling it Outcome 4.
Why? If the math matches perfectly to 16 decimal places, why not declare victory and write the textbook?
Because a mathematical correspondence is not a physical mechanism. They prove that the intrinsic mathematical object, the amplitude structure, is identical in both their geometric theory and TSVF.
Okay.
But they admit they do not yet know the actual physical protocol that the universe uses to select this mechanism. Why does the universe utilize this specific backward time overlap to generate reality? The structural match is a fact. The reason why is an open question.
Which brings us to the final act of this deep dive, Section 7, the tightrope. Because we are talking about backward traveling time vectors, negative mass, the continuum as a mathematical quotient, and the twisted shape of nothingness. This sounds dangerously close to pseudoscience. How did this team protect their work from devolving into, like, late-night dorm room philosophy?
The internal documents explicitly acknowledge this exact danger. They state that the entire program walks a continuous tightrope.
How so?
On one side, you have the absolute necessity of rigorous derivation, the hard, unyielding math that makes a physical claim testable and falsifiable. But on the other side, they must fiercely protect their initial visionary insight, that twisting figure eight of full zero from being flattened. They call this threat monotonic deflation.
Deflation, like when you take a profound, complex idea and flatten it into something that is mathematically easy to handle but entirely devoid of its original meaning.
Exactly. Standard physics is notoriously guilty of monotonic deflation. When it encounters a mystery it cannot solve, it often just draws a box around it, labels it a fundamental axiom, and refuses to look inside.
Right.
The wave function collapse is the prime example. Standard quantum mechanics basically says the observer looks and the wave collapses. It treats collapse as an impenetrable boundary.
It's like ancient map makers drawing the edge of the world. Standard physics gets to the cliff of the observer effect, puts up a sign saying, "Here there be dragons," and walks away. But the framework we are looking at today refuses to accept the cliff. They're trying to build a ladder down the rock face to see exactly what the dragons are made of.
They systematically fractured the concept of collapse exactly how they fractured momentum earlier.
Tell me how they broke it down.
They broke the action of the observer down into a sequence of distinct operational stages, labeling them O0 through O5. O0 represents a state of no physical coupling whatsoever.
Yeah.
O1 is path marking, which is a minimal physical interaction. O2 is the formation of a stable, irreversible physical record in the environment. And O4 represents conscious, cognitive awareness of the record.
So they refuse to just say the observer collapses the waves. They rigorously demand to know at which exact operational stage do the observable statistics of the universe physically change.
Exactly. Does the wave collapse when the photon physically hits the glass lens? Does it collapse when the digital sensor burns it into a hard drive? Or does it only collapse when the human eyeball reads the screen?
By breaking it down, they make the boundary permeable to investigation. And to ensure they didn't lose themselves in the speculative weeds, they instituted severe internal guardrails. The documents utilize honest status labels.
Yes.
Every single claim in the entire program is rigidly categorized as an established fact, a candidate theory, or an open problem.
The prime example of their honesty is the parameter alpha delta, the action scale normalization. They explicitly state in the memos that this critical number is currently supplied by hand, not derived from the geometry.
Right, they admit they couldn't find it.
Yes. And because of this single missing link, they classify their entire multi-year architecture not as a finished discovery, but strictly as a well-built proposal.
They also utilized phase series staging. This basically meant keeping their wildest pre-theoretical ideas completely quarantined from the active, formal derivation lanes until those ideas matured enough to be tested mathematically.
Right, keeping the speculation in check.
And their ultimate calibration tool for the entire framework wasn't some theoretical anomaly. It was the absolute bedrock of quantum mechanics, the double-slit experiment.
Yes, the ultimate test.
The classic experiment where firing single particles through two slits creates a wave interference pattern, proving particles act like waves when unobserved. Standard physics uses the double slit to basically say reality is weird.
But this program uses the double slit as a strict calibration metric. They demand that their new relational mechanics framework must perfectly reproduce the known macroscopic realities of the double slit, while simultaneously explaining the hidden relational gears that actually cause the interference pattern to form in the first place.
It is the ultimate exercise in scientific rigor. True rigor does not mean ignoring visionary radical insights. If they had ignored the initial vision of the twisted figure 8, they would have derived absolutely nothing.
Exactly.
But true rigor also demands that you do not blindly accept the vision. You must subject the vision to the harshest mathematical light possible. You systematically dismantle the black boxes to expose the mechanisms inside.
That's the only way forward.
So let's take a breath and look back at the immense territory we've covered today. We started in the absolute dark, with a vision of full zero, a substrate saturated with resonance, twisting into the infinity topology of a figure 8. We watched that abstract geometric tension pay rent in the real world by calculating the mass ratio of a proton and an electron to a staggering 0.0000705% precision,
Yes.
pulling the mass out of the literal angles of a four-dimensional hyperjoule.
And we saw how that very precision triggered a conceptual crisis, forcing the researchers to fracture our most basic, trusted umbrella terms like momentum and back action into dozens of distinct, incompatible pieces.
Which cleared the ground for the three-layer architecture. The unobservable raw data of the relational mechanics substrate, the ruthless compression algorithm of the resolution mechanics filter, and the macroscopic reality of the oscillatory dynamics layer we live in. We learned that the continuum of space is not a blurry photograph, but a mathematical quotient born of our own lack of resolution.
And finally, we saw how the observer is just a bounded physical control loop, riding the overlap of a fake past and a fake future, sparking reality into existence through the tension of time itself.
It is a framework of reality that is breathtaking in its mathematical scope, yet terrifying in how much of our basic intuition it demands we completely unlearn. As we wrap up this deep dive, I want to leave you, the listener, with a final thought. Something to take with you as you step away from this audio and back into the oscillatory dynamics of your daily life.
I'm curious what you've got.
Think deeply about the concept of smear as quotient in your own world. Not just in physics, but in how you navigate reality. When you label a deeply complex, multifaceted human being as just a coworker, or when you label a massive, chaotic societal event as just the news, you are acting as a resolution mechanics aperture. You are actively declaring millions of tiny relational distinctions as equivalent so you can compress the data and navigate your day without being completely overwhelmed.
That's a profound way to apply it.
But remember, the absolute law the physics taught us today. The smear residue doesn't just disappear. The universe forbids you from deleting data for free. The suppressed structure, the details you ignored, the complexity you quotiented out, it always returns.
It always leaves a ghost.
Right. It returns as a memory kernel, constraining your future. It returns as structured noise disrupting your present, or it returns as a dynamical back-action force you never saw coming. So as you go through your day, ask yourself, what suppressed structures have you aggressively filtered out of your own perception, and how are they about to return into your reality?
A phenomenal question that perfectly bridges the gap between quantum mechanics and human experience. The filter defines the reality, but the residue defines the future.
Thank you for joining us on this deep dive. Keep questioning your apertures, keep looking for the smear residue, and we'll see you next time.